All right, homework 7.2. Let's write our names on it now. Miss Oxley, whatever your period number is. Now, we're talking about the same thing as we have been in the last 2 days in class. So a lot of the confusion comes from when you're going away from the detector and when you're getting closer. So I would go ahead and put a little note for yourself that farther up it is on the y-axis, further away it is. If you're getting closer, you're getting towards the x-axis. And if you want to think about it, you can think about the detector living right down here on the x-axis. All right, so let's see what it says. Sketch a graph, elapsed time and distance. So it's elapsed time down here, distance here. Notice how they put x, comma, y, just like we do in a coordinate pair. For each description, keep in mind that you must walk for the full 10 seconds. So I can't just stop ahead of time. And I cannot travel farther than 10 feet from the motion detector. So I've got to walk all 10 seconds, and I can't go further than 10 feet away. So you start at 3 feet. So 1, 2, 3. I start 3 feet away. I walk slowly away, so I'm going to be up towards the corner, somehow up, but I'm going to be close to a flat line. So almost flat, all the way to the 10-second mark. I made it all the way to the 10-second mark. It's pretty slow, and it's away from the motion detector. All right, B. B says you start 2 feet from the motion detector, so 1, 2. And you walk quickly away. Again, remember, away is up here. If you need to write away and closer on each graph, you can definitely do that. Now it's going to be really quickly. So here's a flat one. So quickly would be much closer to straight up. But here's the thing. If I go right here, I've only walked 1, 2, about a little over 3 seconds. So that's not going to work. I've got to walk for all 10 seconds. So my graph would look like that. I've got to walk for all 10 seconds. All right, let's try this one. You start 7 feet, so there's 5, 6, 7 feet away, and you walk slowly toward the motion detector. Remember, towards is the same thing as closer. So towards is down here, away is up here. So we're going to walk slowly toward the motion detector. All right, I have to walk all 10 seconds, and so I go as slow as I can, walking 10 seconds, and I'm walking towards it. I get there in 10 seconds. All right, you start 9 feet from the motion detector and walk quickly toward the motion detector. So we start at 9. Remember, here's away, and here's towards down here. So we start at 9 feet and we walk quickly toward the motion detector. So a little bit steeper and towards. All right, E. You walk toward the motion detector, stand still, and then walk away from the motion detector. So you've got to walk toward it, stand still for a minute, and then walk away. It didn't tell me how far away I am, so I'm going to start somewhere up here. And it didn't tell me my speed. So as long as your graph looks like you're walking toward it, you stand still for a little while, and then you walk away from it for 10 seconds, you're good. Remember, you have to walk for the whole 10 seconds. I walk towards it, towards it, towards it, towards it. I stand still, I stand still, I stand still. I walk away from it. All right, F. You stand still. So let's say he starts at 5. You stand still for a while. That's a straight line. You walk away. Remember, you can write away and towards here on the bottom. So you stand still, you stand still, you stand still. You walk away from the motion detector, then all of a sudden back toward the motion detector. So you're standing still, you're walking away, you turn around right here and walk back pretty quickly. I didn't make that full 10 seconds, so I'm going to erase that. Whoops. I'm going to erase that and make sure I have the full 10 seconds taken up. All right, next part. It says Mark is running in a foot race. The graph below shows Mark's distance from the finish line as as related to time. Use the graph to answer the following questions. So this x-axis, or this y-axis says distance in miles. I'm going to go ahead and add something here because it's not just it's not the distance he's running. It's distance from the finish line. So distance in miles from the finish line. So obviously the closer I get to the finish line, my distance from the finish line gets smaller. So if I'm 8 miles away right now, I run a little bit, I'm 7. I run a little bit more, I'm only 6 miles away. I run a little bit more, I'm only 5 miles away. All right, so we have to use the graph to answer the following questions. Let's use a bit of metacognition here. I see right away that for, here's 20, here's 25, for 10 seconds, he stands still. I see that for 5, 10, 15, 20 seconds, he's running and he's getting closer to the finish line at a steady pace. So after he takes a 10-second break, he runs a little bit slower. Look how nice and fast he's running here. It's almost straight down. This guy is a little bit flatter. He's still getting closer though, so he's walking or running slow, but he's still getting closer. All right, now let's see if we can answer some of these questions. It says, how long is the race? Well, he started 8 miles away, and he got to 0 miles away, which is the finish line, in 55 minutes. So it took him 55 minutes total. How long did it take Mark to finish the race? Oh, I answered this incorrectly, I apologize. How long was the race? They want to know, not time, they want to know distance. So the distance was 8 miles. He started 8 miles away, and to get to the finish line, he ran all 8 miles. How long did it take Mark to finish? That's the 55, I apologize. Write a story about Mark's race. All right, well, he started 8 miles away from the finish line. He ran for about 20 minutes. Then stopped for 10 minutes. So again, this whole time he's running really fast for 20 minutes. He stops for 10 minutes right there, and then it takes him another 25 to get to the finish line. So he starts running again, but slower. But slower this time.